believe it or not. All right. So here we go. Where are you going, James? You forgot what?
I forgot what time classes started.
Well, where were you?
I was at the piano.
Oh, okay. And your teacher didn't say, hey, time to go?
No,
It's Mr.
did, but
He
didn't have to be the piano.
All right, so here's the quiz that you could have taken this morning. Let's do it for a little bit of review. All right, so here we go. This is our review. Please get out a piece of paper and write this down. Because guess what happens on Monday?
Quiz.
We have a real quiz. Yep, we do. So here we go. Write this down. Got a sheet of paper. Put at the top, practice quiz. And here we go. All right, so the first question says, find the coordinates of AB. Now, it doesn't say that. All it says is this. But what that means is, find the coordinates of AB. So we're talking about the vector that's going from A to B. So what would that be? The vector going from A to B? 1, 7. That's it. We're talking about moving from 3 to 4 and moving from -2 to 5. Got it? How about this one? All right, so first thing we have to do is figure out what AC is. So we're moving from A to C now. So I'll do that down here. From A to C. What is that? -5. +3. Now, what does that 2 tell me to do? Double it all. So that will be -10, comma 6. All right, now we're doing this. All right, so this is, oh wait, I need a problem. That's given. Those are vectors. Here's the question. All right, what's that absolute value mean? Magnitude. So we can do that with a picture or without a picture. Remember, magnitude means, we're doing a practice quiz stuff, this paper. Magnitude means if we draw a picture, we're going to go left 1 and up 4. So this vector is going to look like this. Right here it is. Right here's the vector. Left 1, up 4. Vector U. So how long is it? Do the Pythagorean theorem. How long is it? Root 17. Now, somebody that took the quiz didn't listen to me when I said yesterday, forget the negatives in the Pythagorean theorem. What happens when you square? They're all disappear. But somebody said -1 + 16 and got root 15 as the answer. The negatives are gone. No negatives in the Pythagorean theorem. All right, now I want a unit vector. A unit vector for vector V. All right, now who remembers, you gotta remember this, this is a little bit different, a little harder. Who remembers how to find a unit vector? Jonathan?
Don't you use like sine and cosine?
No, we don't use sine and cosine. We use sine and cosine for something, but not unit vector. Austin?
No, we put it over, let you get this one.
Exactly. Now, this is V, not U. So the first thing I'm going to have to do is find out how long V is. I'm doing vector V. What is the magnitude of V? do what you did right here, but do it with these numbers. Root 13. Now, you don't have to draw a picture of that, but if you can't do it without a picture, draw a picture, kids. Over 3 up 2. See where we got root 13? Now, to make it a unit vector, like Austin said, we're going to take these two numbers and we're going to put them over root 13. There's your answer. How do you make something a unit vector? You divide it by its magnitude. Period.
Wait, so for you, we are just finding magnitude?
Mm-hmm.
Okay.
Yep. This was the question for you. And then this was the second question. Okay? And then there's one more question that uses those vectors. One more. This question, this would be number 5, says, what's this? Now, what do these absolute value bars mean? Magnitude. They have nothing to do with positive or negative. Nothing. They're magnitude, Pythagorean theorem. When you see these bars, you're going to do the Pythagorean theorem. But before you can do the Pythagorean theorem, you got to figure this out, right?
Yeah.
All right, so what's 2u? 2u. Negative 2, 8. Right? Minus v. All right, so let's subtract. Negative 2 minus 3.
Negative
8 minus 2. Now that is this. Would you agree with that? Now I need to find its magnitude. Has nothing to do with negative and positive. It's the Pythagorean theorem. So if I go over 5 and up 6, how long am I? Square root of 61, 25, and 36. The square root of 61 is the final answer to the problem. All right, now we're going to do the one Jonathan was talking about. The last question on the quiz was this. You have this vector. Find the components. And by components, remember another word for that is coordinates. C-O-C-O, coordinates, components. What are we talking about? X and Y? This is what we want. We want X and Y. And we can find X and Y by using sine and cosine. So the cosine of 61 equals X over 10. And the sine of 61 equals Y over 10. Cosine, always X. Sine, always Y. Always, always, always. So then I type in my calculator. I need a calculator to do this. I type in X equals 10 cosine 61 and Y equals 10 sine 61. So I just type that in. So 10 cosine 61. And my X coordinate is 4.85. And 8.75. Now, what do I have to be careful about with a lot of these problems? Leah? Yeah. Are there any negatives? Now, look at this problem. Do I need to worry about it with this one? No, because I'm in the first quadrant. But you do have to be on the lookout for that. Okay, that's review. We are having a real quiz. This one today, this morning was optional. Some of you took it, some of you didn't.
No.
Huh?
Let's have one right now. We are.
No.
But we're doing
This
another
is
one
for
right
it
now.
said before school. But on Monday, we'll take it during class, we'll have a real quiz. Okay?
My bad.
So we need to know this stuff. Jonathan,
I'm sorry.
okay?
Yep.
All right. Now, what else do we need to know? All right, so we're in our note sheets. We're looking at problem number 7. Right? So here we go. Problem number 7. Find the magnitude and direction angle for the vector 3, 2. I am in my notes. I'm in section 6.1, which is a huge section, and I'm doing problem number 7A. That's where we left off. Right? We didn't do this section yet, did we? No, I didn't think so. All right, so this is problem A, and it says find the magnitude and direction angle. Now, magnitude you already know. What's the magnitude? You already know how to find that. This is the magnitude, root 13. How do we find magnitude? Pythagorean theorem. Now, direction angle. That's this guy right here, folks. That's the direction angle. I need my calculator. Bailey's getting it out over there. Her calculator. When I find an angle on my calculator, I have to use my special button. You remember that? So special sine, special cosine. Actually, we're going to use tangent because what do we know about this angle? We know its tangent is 2/3. So we're going to type into our calculator second tangent 2/3. That's how I'm going to get my direction angle. Every time I'm going to use second tangent. So second tangent 2/3 is 33.69. That, my friends, is the direction angle. So your direction angle is 33.69 degrees. That's all there is to it. How did I get my direction angle again? What buttons did I press? Second tangent. Y over X. Let's look at the next one. Same thing, only it looks like this, over 1 up 5. This is my vector now, right here. Left 1 up 5. John, you following? Okay, this is D, letter B. What's my magnitude? Everybody gets that one right. What's my magnitude? Root 26. Pythagorean theorem has no room for negatives. 5 squared, 1 squared. 26. Now I need my direction angle. So I'm going to find this angle right here. And I'm going to do second tangent 5 over 1. Now, you don't need to put the negative in. If you want to put the negative in, you can, but then you're just going to get a negative answer. And it doesn't really make sense that that angle there is negative. So I would just leave the negative out. All the negative really does is get you graphed right. After that, you don't need it anymore. So second tangent 5, I got 78.69. Did you? Now, do you think your direction angle is 78.69? I'll give you a hint. It's not. What would that direction angle be? It's this one. That's your direction angle. Gang, direction angles start right here. So you got to go all the way around. So how am I going to get that number? Subtract from 180. Bingo. Good job, Joseph James. So that's gonna be 101.31. Double check my arithmetic. I did that in my head.
Yeah.
Is that right? Everybody okay? Look at the next one. We're doing the same thing. -3, -6. I need the magnitude and the direction angle. Now this is your magnitude. What's my magnitude? Square root of 45, which is very good, 3√5, perfect. Now I need my direction angle. How do I find that little angle right there in the triangle? What button do I press? Why, Mrs. Ford, you press second tangent. Second tangent what? 6/3, or 2, if you're gonna just do 2. But like our last problem, I got 63.43, but that is not the direction angle. The direction angle has to get you all the way around to here. How are we gonna find that one? 180 plus, so that would be 243.43. Okay, how did we get this one? 180 minus, because we backed up from 180. How did we get this one? 180 plus, 180 plus. We got one more. Over 1 down 4. This vector in problem D goes over 1 down 4. What's my magnitude? √17. Now I need my direction angle. What am I going to press on my calculator to find this angle right here is the one I'm going to find. So I'll press what? Second, turn it on for second tangent. 4/1 or 4. 75.96. Now that is not your direction angle though. This is your direction angle. Subtract it from 360. Very, very good. Oh, I'm not even going to try this in my head. I'll mess it up. What is that? 84.04. Thank you. So in quadrant 1, that was my direction angle. It was all good. How did I get it here in quadrant 2? I had to do 180 minus. In quadrant 3, I did 180 plus. And in quadrant 4, I had to do 360 minus. Notice, do I at any time use 90 or 270? Never. Okay, now number 8, here we go. These are like word problems. Let's see. Find the component form. All right, what do we mean by components? We've already talked about that. The components are the same as the coordinates. So it's x and y. So we want the component form of the velocity of a plane flying on at a speed of 410 on a bearing of 200. All right. Are you writing on the desk?
No.
You better not be.
No.
All right, here we go. Who remembers anything about how we draw the course of an airplane or a ship? Well, we use our compass. And on our compass, it's different than it is with other math. 0 is at the top of the compass. And this is 90 and 180 and 270. So when this problem says the plane is flying on a course of 200 degrees, I am going to draw it right here. Would you agree with that? This angle is 200 degrees. Now I'm going to make my butterfly bow tie triangle like I always do. And the problem wants the coordinates, the components. The problem wants to know what are the x and the y that go with this picture. Now, do I know anything else about the triangle? Read the problem, look at the picture. Do I know anything else? Liam? This would be 70 degrees. Does that make sense to everybody? Look at the setup. Look at the configuration that we have. Does it make sense to you that this guy would be 20, so this guy has to be 70? Now, I know one more thing. Read the problem. There's one more piece of information I can put in my picture. I know the speed is 410, so the length of that vector is 410. Now, take a look at, I know there's a bunch of stuff in this picture. Let me get some of it out of here. Can you solve that triangle? Can you find x and y? How do we do that? Sine and cosine. It's exactly what we did before. We're going to say cosine 70 equals x over 410. And sine 70 equals y over 410. So x equals 410 cosine 70. And y equals 410 sine 70. So your job is to find x and y. Now you can do it. I got 140.23. And 385.27. Now, be careful. Look at your picture. Do we want to make any changes to that? They're both negative. Why are they both negative?
Going down.
You're going down and left. You're in quadrant 3. Remember, you need to put those negatives in, right? You need to pay attention. That's why we draw the picture. All right, B says, do it again. But the speed is 510 and the course is 310. All right, so here's my compass. I'm using a compass because this is a plane flying problem. Where am I going to put a course of 310 degrees? Yep, up here, right? So this is 310. Now we'll make our butterfly bow tie. And we want X and Y. That's what we want. Now maybe before we even get started, what can you tell me about X and Y in this picture? X will be negative, the Y will be positive. So I might mark that right now. Okay, so this is 310. so this is 40. Would everybody agree with that? That's a 40. Look it over. And what about the 510? That number in the problem, where does that go? That's your length, that's your hypotenuse, it's your magnitude. So now we're ready to do just what we did before. We've done a few of these. What's x going to turn out to be? 510 cosine 40. And what's y going to turn out to be? 510 sine 40. So I've already taken care of my positives and negatives. So I'll just type it in. All right, tell me what you think. You okay with that? That's not too hard, is it? You're having the time of your lives. Oh, look, a football problem. A football is thrown at a 53-degree angle with the horizontal with a speed of 12 meters per second. Find the components of the velocity vector. Okay, now this is one of those problems that sounds so hard, but it's so simple. The ball is thrown at a 53-degree angle with the horizontal. So here's the horizontal, 53-degree angle. So there's the ball. Here you are, throwing the ball. A speed of 12. Where do you think we're going to put that 12? Hypotenuse. Because what is the question asking me for? The components. And the components are x and y. Components, coordinates, same thing. Bless you. Okay, so what's x going to equal, guys? You've done a bunch of these. X is going to equal what? 12 cosine 53. Remember, x always goes with cosine. And then y equals 12 sine 53. Now this time, when we find our x and y, will we make any of them negative? No. So let's see, 9.58 for y. And 7.22, does that look about right? One more of these. I think you're getting the hang of it. They're pretty easy. Okay, so we have a force of 3 pounds. Forces are often, the unit of forces is often pounds. You've heard of like pounds per square inch and stuff like that. That's a force. So we've got 3-pound force acting at an angle of 18 degrees. And we want to find the components. Now you're probably getting almost, I know math is never boring, but you might be just on the edge of being bored here. What's x? 3 cosine 18. And y is 3 sine 18. There are the components of the force. What do you think? You okay with that? Lordy, that's 6-1. That took forever. There's a lot of stuff in 6-1, but a lot of it's the same. We did a lot of problems like this. Okay? All right, we're going to do a little bit of 6-2, and then you can go to lunch. Yeah, I want to do the first part of 6-2 before you go to lunch, because I know how much you all just love to come back after lunch, because you told me. It's okay. My self-esteem can handle it. All right, so here we go. First thing we're going to do in section 6.2 is find what we call the dot product. In vector land, this means something different than this. They're different. This is called the dot product, and this is called the cross product. And they're different. So today we're going to look at what's called the vector dot product. It has a dot. And when I say that, like if I were calling somebody on the phone who's absent today and saying, hey, we talked about v dot u today. That's how you say that. V dot u. Don't say times. Because if you say times, we don't know which of these you mean. So you either say v dot u or v cross u. Now we're not doing the cross product today, so it's just dot today. V dot u. Now let me show you how you do it. Let me do this problem, and then you tell me what's going on. It's 1 times 2 plus negative 2 times 3. So the answer to the problem would just be negative 4. All right, so take a look at the problem and tell me, how do I do a vector dot product? What do I do? I took x times x, y times y, and add them up. So when I multiplied my x's, I got 2. When I multiplied my y's, I got negative 6. When I added them up, my answer is negative 4. So if you're taking notes, we multiply the x's, multiply the y's, add them up. That's how we do a vector dot product. So let's look at the second problem. Problem B. Problem B. We are going to find the dot product of negative 1, 6 and 3, 1. So how do we do that again? X times x, y times y, and add them up. So what's the answer to problem B? 3. Got it? All right. What's C? Do number C, the letter C. What's the answer to C? Negative 2 plus 0, which would just be negative 2. And the answer to D? 0 plus 24, so it's just 24. So x times x, y times y, add them up. That's called the dot product. Okay? Now we're dying to go to lunch. We're starving. I hope there's something good today. Let's have you back in the fish dish. Let's have you back in your seats at 12:21. 12:21. Jake, can you hit the off button there?
Yeah.